recording. So, I finished grading PA1, but I haven't posted the grades yet. But they looked fantastic. Okay, everybody seems to know how to make a class and constructors and methods, and that was the real goal of this exercise, right? And everybody nailed it. So occasional issues with the two-string method, right? Which I've got feedback that I'll post in Canvas about that. But yeah, I think people are in good shape right now as far as objects. So PA2 is, taking that a step further and starting to use objects that are comprised of other objects. So I think that will be successful. All right, I want to dig into some details. So PA2, you're going to process a file, so you need to be able to open up a file and ingest from it. So let's play around with the scanner class. So we can construct a scanner using this kind of invocation. And if you look at the documentation on a scanner, it's got a few options for constructing it. One is to construct it off of standard in, which we do when we want to just read from standard in, so you construct with system.in. But if you want to read from a file instead, easiest way is to make a new file object and construct that file object with the name of the file you want to read. Okay, so you have a file named My Numbers, for example. Construct a file object from that, and then feed that file object to scanner. Okay, so let's look at this file class. And it's a way for interacting with files, okay, not surprisingly. A file object can be constructed, the way we're doing it is just passing a path name. Okay, but there's other ways that you can do this. And once you've constructed a file object, you can use it to interact with the file. For example, you can tell, is the file executable, is it readable, is it writable, and so on. You can also tell whether or not the file exists. Okay, which is useful to know. So let's play with files first. So you need to import from Java IO file. And since we're going to use scanners too, let's import from Java util scanner. And one thing I saw on some of the PA1 submissions, for PA1 you did not need to import anything. You need to use things from the string class, for example, but string is already available to us. Okay, most of the things we used so far are already available. You don't need to import anything. So this is something you do when you're using a class outside of the usual, for example, file scanners, or linked lists, or hash maps. So let's hold off on the scanner for now, and let's just make a file object. File f equals new file, haha. And let's print f and see what it returns. Actually don't know what it's going to give us. So it prints out haha. So it's just printing the name of the file. So let's interact with this. Let's look at the exists method. Right, and it tells us f.exists equals false. Now if I create a file named haha, now f.exists returns true because I've got a haha in my directory. And if I make that file permission 0, 0 so that I cannot read it, I can still examine it with the exists method and it'll tell me that it exists. So let's look at can read. Alright, so if I do this, the file exists, but I cannot read it. If I make it readable, the file exists and I can read it. If I remove it, the file does not exist and it tells me I can't read it, which makes sense because you can't read a file that doesn't exist, although that's kind of an existential question. But anyway, so different methods we can use in here, right? And they're really for interacting with this notion of a file. It's a handle to a file, right? This is not going to throw an exception if your file doesn't exist, or if you try to create a file off of something that you don't have permission to do anything with, or even something that you don't own. Okay. But here's what can happen when we try to create a scanner object. So let's get rid of these. Let's create a scanner from that file. Now when I try to compile, I'm going to get an error message. And it's going to say unreported exception, file not found exception must be caught or declared to be thrown. So if we look at scanner, right, when you construct it says it throws a file not found exception. All right, and all of these methods and constructors potentially throw exceptions. So we can, click through on this because exceptions are objects also. And here's all the information about a file not found exception. So we could construct it like this if we wanted to. And it has methods that we can call. Okay, methods inherited from. Remember, classes are extensions of other classes usually. We'll play with this more in a few weeks, but a file not found exception is an extension of an IO exception, which extends an exception, which extends a throwable, which extends an object like everything else. And the throwable method has all of these, the throwable class has all of these methods available. So for example, the get message method in throwable, which is also available in file not found, returns a detail message string of this throwable. All right, so what does all that mean? Let's put that together. So first of all, let's deal with this exception, okay? File not found exception. So here's one way to deal with exceptions, but I don't want you to do this, okay? This is a kind of sloppy way to do this. What's happening right now is when we try to compile Java, main.java, it's realizing that it's possible when we run main, it's going to get an error and it's going to print out a message about that because we haven't told it what to do. We can say that's okay. I understand that this main method might cause an error, but we have to tell the compiler that we know that. So we can say this public static void main can throw an exception called file not found exception. Okay, throws just mean, causes. So once we do this, right, it will say, oh, okay, well, yeah, this could cause an exception down here, but you've already acknowledged that, this method may cause an exception. Okay, so this will still not compile because it doesn't know what file not found exception is, right? So in the documentation, if you look for that, that comes from java.io. So we need to import that as well. So we'll import that, and then that will compile. And now when I try to run it, yeah, it gets upset because there's no exception, no file named haha, and so it just prints out this message, and it basically says at line 12 something went wrong, right? In particular, haha was not found, no such file or directory, right? And that's line 12 that we're sitting on. All right, but I prefer you not do this, okay? Because it's really saying, you know, let errors happen where they happen and they can just appear on my screen. And like in 222, 223, I told you I never wanted to see a seg fault from your program, okay? It's a very uncontrolled way to handle a situation. It's better to avoid them or do something reasonable if they're going to happen. So throwing is not the best strategy. So the better strategy is to use a try-catch block, okay? And a try-catch block looks like this. We have some statement that might cause an exception. Before we execute that, we use the keyword try and we put in a curly bracket. And we put our statement in between these curly brackets, and it's a separate block of code. It's like putting something in an if or a while. It's in a try block. And then after this curly bracket, we can say catch, and we can define a catch block, and we can put anything we want in here. And here's the deal. We're executing code in our method. We come down to the try block, so we try to execute this statement. If it succeeds, it jumps down here and continues with our code. But if this statement fails, it will jump down to this catch block and it will start executing these statements. And then when these statements finish, it will continue with our code after the try catch. So if no exception occurs, right, putting this in a try catch block, all it does is execute the statement and then continue here. The catch piece is completely ignored. But if an error occurs in that statement, now it executes what's in the catch, and then it continues. So it's a way to do more controlled error catching, error handling. All right, now we need to put something in these parentheses where we say catch, and it kind of looks like a signature on a method, okay? We're going to put in a type of object and then a name of an object, and it's kind of acting like a function call. So we can say something like file not found, exception, and you know, just the name of an object. I'll just call it X here because I didn't leave enough space. And basically, if a file not found exception occurs in here, the system will look for a corresponding catch block which expects an argument of type file not found exception. And if it does, it will kind of call this, right, except there's no return, but it'll jump down here, and this object, this variable, will be given the value corresponding to whatever the exception is that occurred. It'll become a file not found exception. Okay, so code will make this clearer than more commentary. So let's do this. So constructing the scanner could cause an exception. So let's use a try catch block. So we'll say try, and we'll do that. So if something goes wrong, we will catch I'm having issues today. So we'll say catch file not found exception, and we can call this whatever we want, right? I'll just call it all our error. Okay, so this code is executed if an error occurs. If no error occurs, this is skipped. Alright, so we'll try to open the scanner. If an error occurs, let's just print a message for now. And we'll say something went wrong. So we'll continue after the try catch block, and let's just print another message. Just so we can kind of see what this is doing. Alright, so let's compile that. And we'll go, and then let's go ahead and run it. So we got the message saying something went wrong, and then it said we're outside the try catch block now. So we started executing, made a file object, no problem. Tried to construct a scanner. File did not exist, haha, so it jumped down to the catch code, which is in here, printed that message. And then it continued with, we're outside the try catch block now. Now if haha existed and we ran this, it skips over the catch block and it just says we're outside the try catch block now. Alright, so so this business of r-error, right? R-error is a file not found exception, okay, which is a type of object, okay, and we can call these methods. For example, we could call the getMessage method. So let's use that. Something went wrong. Let's go ahead and add r-error.getMessage. Let's append that to our output. And let me remove haha and run Java main. And now it says something went wrong, colon, haha, no such file or directory. So it's telling us exactly what's happening. And you can get all sorts of information available from this file not found exception object, right? You can get the message, which is a string. You can print the stack trace, which is what it normally prints when you don't handle an exception. That's that, you know, all of this stuff. That's the stack trace, basically telling you who called whom and from where. And you can get other information, right? You can get the cause and so on and so forth. So stuff to look at, right? All right, so a disclaimer here. You notice that I put this try statement around one line of code, which could potentially cause an exception, okay? I could get away with putting the entire thing inside a try statement. In fact, you can take your whole method with 100 lines of code and you can put it all in a single try block and then just put a catch block at the end. And that will stop you from having to think about exceptions, okay? But don't do that. Unless you're just trying to get something to run really quickly and you're in a urgent rush, right? Don't do that, because that is really sort of very coarse error handling. And, you know, most exceptions should not occur. Okay, if an exception occurs here, something unusual is going on. For example, the file doesn't exist, or the file's not readable, and you want to do something about that. If I put everything in one big try statement, any exception anywhere, divide by 0, file does not exist, out of memory, is going to bring me to the same catch statement, right? And I can nuance it by specifying the type, but anyway, make your try blocks as tight as possible, okay? Just put in the statement that could possibly cause the problem, right? And will it work if I do this? Yeah, absolutely. That'll work fine, but better form, just put in the things that can actually cause the exception and keep everything else outside. Okay, so here's what I'm going to do. Let's go ahead and read from this file. So SC is a scanner object. Scanner objects come with this hasNextLine method, right? So bunch of methods inside scanner. The one we're going to play with right now is hasNextLine and nextLine. So hasNextLine returns true if there's another line of input, and then nextLine reads that next line of input and returns it as a string. So if we want to read our file one line at a time, we can do the following. Well, SC hasNextLine. Let's set a temporary string called buffer and set it equal to sc.nextLine. Let's print it out. And then let's just continue looping. So compile that, and I'm getting an error. It says it does not know what this variable sc is. Okay, in the class main, cannot find symbol. Well, you know, I told it right here, sc is an object of type scanner. Why is it telling me that it doesn't know what sc is? So here's the other thing. A block like try is like a while loop or a for loop. If you define a variable inside this block, it is local to this block. So saying scanner sc in here, sc ceases to have any meaning once I get beyond this curly bracket. Okay, so in here, sc is undefined. So what I can do is I can say, let's define sc outside of that block. Remember, there's two things going on in programming language. There's declaration of a variable. This is saying sc is something of this type. And then there's actually initialization, or for us, construction of the variable. Here we actually set sc equal to a scanner. Alright, so we can compile that, and now what's it telling us? Sc might not have been initialized. Okay, it's saving us from ourselves. Because guess what? We make f a file corresponding to haha. We try to make sc a scanner that'll read from haha. Suppose something goes wrong. Suppose haha does not exist. We will jump down to the catch block. We will print this message, and then we continue. We're outside the try catch block now, and now we start trying to use sc. Well, sc has not been given a value because we tried to give it a value here, but the scanner constructor threw an exception. And so we never finished this statement. We came down to the catch block. Sc is uninitialized. So it's actually telling us something. It's telling us that the way our code is written, it's possible that when we get down here, sc has not been given a value. Okay, that, you know, remember, when you get errors, don't just try to make them go away. Try to understand why the error is there. Because, you know, when we write code, we're not just randomly hitting keys. We're trying to make something happen, and if what we're trying to do is not what happens, or if it doesn't compile, right, we want to understand where that disconnect is. We want to understand why did something different happen from what I expected. So try to dig into this. And here's an example of what not to do. It's telling me that sc is uninitialized. If you go on Stack Overflow or Code for Geeks or something, you'll find people who will offer you advice and say, oh, just initialize it to null, right? And so you initialize sc to null, and when you compile, your error goes away. Well, that looks great, right? Until you try to run it. And when you try to run it, you're going to get an exception. And it's an exception we're not handling, right? Which says null pointer exception. And it's down here at line 25, which is where we're trying to use sc. So if we didn't do this, and we try to compile and we get that error, we want to go into our code and we want to think, why would it be that I might get down to line 25 and sc doesn't have a value? And go back and look at where you give sc a value. Oh yeah, I'm in a try catch block. Okay, chances are if the file doesn't exist, I don't want to start reading from this non-existent file and printing out. I probably want to do something like just give up here. Put a return statement in there. And now if I try to compile, it's perfectly happy because it doesn't see a path to using SC where it hasn't been initialized. So work with the compiler, okay? When it gives you error messages, don't just swat it like a fly and try to make it go away. It's actually giving you useful information. So go ahead and look in your code with an eye towards, understanding that error, and oftentimes you'll save yourself trouble down the road. All right, so this is pretty clean code now, right? We'll open a file, we'll try to make a scanner. If it doesn't exist, we'll print out a message and we'll just exit. Otherwise, we'll continue and we'll go into a loop where we read from our file and print it out. So let's put something into haha. So I'm not feeling very creative today. All right, so there's my haha file. Okay, it looks a lot like my Java code. All right, so let's run our main program, right? And it's ingesting our file and printing it out one line at a time. All right, so that's the basic way to read from a file. Okay, make a file object, make a scanner, and you can do this in one line. You could do SC equals new scanner, parentheses, new file, parentheses, quote, file name, or you can do it in pieces. Have a catch statement, and once this succeeds, right, SC, you can use has next line and next line to process it. And this has next line is important. Right, if I just went into an infinite loop to read from my input file and print it out, it compiles, but when I get to the end of my file, I try to do one more next line, and I'm going to hit this no line found exception. Now I could handle that with a try catch statement, but there's no need for that, right? I don't need to do that because I have a way of knowing if this exceptional condition is going to occur. I have a way of checking whether or not there's a line, which is call the has next line method. Okay, so you could do this, get an exception. Oh, I'll put a try catch block around it, right? Again, try to understand why the code is doing what it's doing, or why the compiler is saying what it's saying. Okay, and in this case, why am I getting this error? Oh, because I'm reading when there's nothing left in the file. Well, go back to the scanner class, look at next line, and you'll see has next line around that, and go ahead and use that. All right, so there's code for reading from an external file one line at a time. So this is similar to using fgets, right? Hold on, I'm looking at my Zoom on my phone. Okay, this is similar to using fgets. But we have other options, and this is not what you want to use in PA2, okay? Reading in a line at a time is not the best way to do PA2, because when you read an entire line, you're really only prepared to deal with one word at a time, right? And so you would need to take that line and you would need to break it up into words and then ingest each word into your index and then go on to the next line and so on. You can do that, but an easier approach is to deal with one word at a time. So in the scanner class, there's a method called hasNext. There's hasNext bytes and booleans and big ints and decimals, but there's also just a plain old hasNext, which says, is there another token? And then if there is, you can get that token by calling next. Okay, so what is a token? It's basically stuff separated by spaces, or end of line, new lines, or end of file. So if we change this and just say has next, and then we call sc.next. Now we're processing our input one word at a time. Okay, so everything that's separated by spaces. Alright, so that's what you really want to use for PA2, but let's look at some other options if we're dealing with a line at a time, because other code we're going to write, we're going to have to do some of this breaking up ourselves. So let's go back to reading a line at a time. And I want to look at the split method. So let's look at the string class. So string class, we've looked at this before already, has a method called split. And split basically takes a string, and everywhere that it finds that string, it basically breaks that into another word. So it breaks your input into a set of words. Okay? And it returns an array. Now we haven't talked formally about arrays yet, other than string bracket bracket in our main method. But we know enough about arrays to work with them. So let's just see what this does. So we're going to read in a buffer. We'll print out what that is. Play with split. So split returns an array of strings, which is just string bracket bracket. Let's just call this pieces equals buffer dot split. And let's split around spaces. Okay, what this is going to do is take each line of our input, and it's going to give us an array corresponding to each word on that line, where a word is just stuff separated by spaces. And it's going to build this array. So let's look at that array. So remember, arrays in Java, you can tell how big they are, you can tell how many things are in the array, and the way you do that is the name of the array dot length. And it's not length paren paren, we're not calling a method here, we're accessing a field. Okay, so any array has a dot length field, which tells us how many things are stored in the array. Okay, this is what we wanted in C and we just don't have. So we can print this out and it'll tell us how many words are in there. And then let's print those out. Well, let's just run this one right now. So import Java IO file, number of words was 2. Import Java util scanner, number of words was 2. Class main, number of words are 2. Public static void main, string bracket bracket args, number of words is 7. 1, 2, 3, 4, 5. I don't know how it got 7. Interesting. All right. Well, so let's print out the actual words in the array. So the space is in the beginning. Okay. So let's look at the pieces array. So we'll iterate up to pieces.length minus 1. So I'll go less than pieces.length. So pieces bracket I equals, and we'll print out the actual value of that string inside angle brackets so we can see what it is, and we're going to see why we got 7 words in some cases. And I forgot to close my for loop. Let's run Java main. And so let's go back to public static void main. All right, pieces bracket 0 is an empty string, pieces 1 is an empty string. Second word is, index 2 is public static void main parentheses string bracket bracket, and then args paren. Okay, so these spaces are separating empty strings, right? Lambdas from 215. That's just kind of a quirky thing about splitting strings, right? Basically, every time that you find a space, take everything between the previous space and this space and throw that into an element in the array. All right, so that first space comes between the beginning of the line and itself, so that's an empty string. And the second space is going between the first space and the second, that's an empty string. And then the third space is right here, and that goes between the second one and here is public. Okay, so yeah, so split basically breaks things up. Now we could split on a comma, and most of our statements don't have commas in them. But this one did, so our input was, if no error occurs, this is skipped, right? So splitting on a comma broke this into two pieces. The first piece was, if no error occurs. The second piece was space, this is skipped, right? The stuff that came after the comma. All right, so you get the idea, right? Now, the cool thing about split is this string is actually a regular expression. Okay, so all the regex stuff from 224 applies here. You can put in more complex patterns and split around those things. So for example, we can list characters inside brackets and say we want to match any of the characters we find in there. So, well, let's split on A, E, I, O, U. So let's split words, input lines on vowels. I have not tried this before. Okay, system.out.print line. So SYST, the E was a delimiter, M dot, and then O is a delimiter and out, and U is a delimiter, so there's an empty line between O and U, and then T dot PR is the next word, and the I is a delimiter between that and the next one, and so on. So when you're processing strings, right, split is a really simple function, but it's pretty powerful. You can start to do some interesting first order parsing with it. Okay. Additionally, there's a whole regular expression class in Java. Yeah, so patterns and matchers. Right, so there's a whole package called regex. And you can basically make a regular expression, compile it, and then take a string and ask if it matches. Okay, you can do this in C too. There's libraries we can use. We don't go over them in 224 usually, but most languages support this. But it's really easy to use in Java. So lots of capabilities, right? If you find yourself working really hard, there's a chance you're reinventing the wheel, which is not a bad thing to do. It's one way to learn a lot of stuff, but you don't necessarily need to do that. All right, so that's lots of stuff about string processing. And again, none of this is stuff you really need to worry about for PA2. Okay, but for later assignments, right, some of this will kick in. So just stuff to be familiar with. Get in the habit of looking at the documentation. Right, there's a link to it on Canvas, and it all looks the same, right? It all has the same basic setup and structure. So once you have looked at these things for long enough, right, you get pretty good at scrolling through all of this and getting down to what you want, which is, say, the methods, right, or whatever. Let me just make a couple of comments about the even class. And yeah, I know I don't have any comments in here really. I slapped this together when I was writing the assignment so I could generate sample output code. But you know, pretend there's lots of comments in here like I asked you to do. So a couple of things to say in here. First of all, I have one class variable. In this case, it's called val. Okay, that holds the value of the even number. I have other variables that I use throughout my code, but if the variables you're using in a method are local to the method, it's best to declare them inside the method, not up here in the as part of the class itself. So my toString, for example, I have a string called result. I have a string called num. I declare those inside toString, and then the scoping on those, the range in which they exist, is just inside this method from here to here. And so if I wanted to use a variable called result somewhere else, right, I can do that. It has nothing to do with this result. If I declare a variable up here named result, right, that's available everywhere in my class, and that's not necessarily something we want. It's basically a global. Okay, but if it makes sense, for example, lots of methods need to access the val variable because that's the value of this even, right? Go ahead and make that a class variable. All right, the other thing I wanted to mention was the toString method. So I suggested in class turning your integer into a string and then walking through it character by character. And a lot of people did that, but there's other ways to accomplish this. So what a number of people did was they took your number. Let's say you want to do the number 258, right? And they divided it by 10, and they got 25. They also did 258 and calculated that modulo 10, and they got an 8. Well, that's the last digit of your number, is an 8. Okay, you can take this 25 divided by 10, and you get a 2. 25 modulo 10 gives you a 5. That's the middle digit of your number. And if you take the 2 and continue, 2 divided by 10 is 0. 2 modulo 10 is 2. That's the first digit of your number. And then once you have the 0, you can stop. So some people did this, and it worked perfectly fine. But it's you know, a fair amount of code to write that. So the approach that I had suggested, which some people did, was if you take your integer and you just append it to an empty string, that will turn it into a string. The system will call the toString method for val. Well, it's not an object, but you know, it'll convert it to a string, append nothing to it, and now num would actually be a string, which is equal to, quote, 258. And now you can tell how many digits you have by looking at that string.length. This is a method again, right? It's not an array, it's a method we have to call, so we have parentheses there. And then iterate across each of those characters, and I just made a convert function that converts the character at position I in our string to a word. So convert just takes the incoming character and returns one of 10 words or 11 words based on that character. And then those words get appended to a string called result. So result equals result plus the next word, and that builds up a big long string. And then as long as we're not at the last iteration through our loop, I go ahead and also append a space to it. Okay, so that's a shorter version of it, but consider this. How does this toString method work? How is the system taking val, which is an integer, and turning it into a string? Well, it's doing something like this, right? So if you did it like this by dividing by 10 and modulo 10, right, it's really good practice. It's great to be able to do that. That's you know, good test code. And that's what somebody had to do to write the toString method for converting an integer to a string. And even more challenging would be converting a float or a double to a string, because now you have things to the left of the decimal point, the right of the decimal point, you might have scientific notation, and so on, right? So these are really cool challenges to work on, right? I definitely recommend if you're looking for more practice, try some things like this, right? Some people did the integer part in PA1, so so that was really cool to see. All right, I think that's all I had to say right now. So tomorrow I want to talk a little bit about arrays because we've been using arrays. So I want to talk about declaring arrays, initializing arrays, and two-dimensional arrays. I want to look at a few more classes, and I want to play around with hash maps. Okay, so I want to put our scanner class together with a hash map class and do some more interactive things and just get some practice, because hash maps are the key, they're the central piece of PA2. So I want to make sure people are comfortable with that. So mess with those if you haven't already started, and we'll spin some code around hash maps tomorrow, and then we'll go on from there. All right, thanks everybody. Have a good afternoon. Watch out for the rain because I think it's coming, and I will see you next time.